Applying integrations to calculate areas under a curve.
The first fundamental theorem of calculus. The first fundamental theorem of calculus states that if f is continuous on the closed interval a and b, and big F is the indefinite integral of f on a and b, then the definite integral from a to b of little f of x dx equals f of b minus f of a. Essentially, this theorem states that for every continuous function f, there exists an antiderivative f of x. This theorem connects derivatives and integration in calculus. Definite integral. Here we're presented with the definite integral from -1 to 4, where the function is 5x to the fourth minus 8x cubed plus 6 dx. We're going to find the definite integral using the power rule.
When taking antiderivatives, the power rule states that x to the n is equal to x to the n plus 1 over n plus 1.
With that being said, we're going to use that power rule and take it of the inner function presented. So that 5x to the fourth becomes 5x to the fifth over 5 minus 8x to the fourth over 4 plus 6x bar -1 to the fourth. Then we're going to simplify that. We're going to cancel out, and we're going to get x to the fifth minus 2x to the fourth plus 6x bar -1 to 4. And then we're going to just take the upper limit, subtract it from the lower limit. By doing this, we can find the definite integral. So we're going to take the whole function and plug in 4. 4 to the fifth power minus 2 times 4 to the fourth power plus 6 times 4 minus -1 to the fifth minus 2 times -1 to the fourth plus 6 times -1. Algebraically, we can simplify this. Now we can simplify all that to 1024 minus 512 plus 24 minus -1 minus 2 minus 6. This can be further simplified to 536 minus -9, which in turn equates to 545. And this is the ultimate solution for this definite integral.
Here's an example of integration in real life. The Cathedral of Notre Dame has these openings called archivolts. Its classical Gothic arches and stained glass windows of the famous cathedral offer excellent examples of areas for students to calculate via integration. Looking at the archivolts closely, you can see that they resemble a parabola. Using the fundamental theorem of calculus, the area of the archivolts can be found.
The Nanyang Technical University, located in Singapore, is a great engineering feat like that of the dome roof of the Pantheon in Rome. Its curved roof is covered in turf to allow the building to maintain a cooler temperature because the average temperature in Singapore is 87 degrees Fahrenheit. On the interior, the heating and cooling system, support structures, and layout of classrooms and dorms were carefully designed to maximize space and comfort. Some other facts on this university: it has a total area of 215,000 square feet. And utilizing integrals, architects were able to design 2 arches that create a walkway and roof above the building. Engineers used integration and other calculus techniques to create the building with concrete, but also to accommodate all the other functions of this building. This building houses a school of art, but also dormitories, laboratories, classrooms, and even 2 full art galleries. Works cited page.